Hey guys, so in this video we're going to talk about graphs. Now I know you guys are familiar with graphs from your years and years of schooling and you've seen them before. Graphs form a really foundational part of physics. And in this video we're going to explain why that is. So the purpose of this video is to introduce you to the reason why we use graphs in physics, and then show you how we can get relationships between variables, which is kind of the main use of graphs that we'll have this year. So when we think about why it is that we use graphs, if say we had a bunch of data of time versus position, and we put it in the table, and it's nice and it's organized. I guess this table doesn't have my units, so I guess it's not perfect. But we have this nice table here, and we can see time and position, but it's very hard to see if there's some sort of relationship between the time and position for the object. In other words, how are these two things related to each other, if at all? And you could do some work, you could do some calculations, and you might be able to get a relationship between them. But it is a lot easier if we just go and we use a graph. So if we were to graph this set of data, we can see very easily that we have this nice line. And what we say is that position versus time for this object is directly related, or it's related in a linear fashion. Okay, and it's much easier to see that with a graph than it would be with a table. So we're going to make a lot of graphs in this class. We're going to collect our data, and then a lot of times either it's going to be output as a graph, or I'm going to ask you guys to create a graph. The reason being is to allow us to see these patterns that exist between the variables. Now, one of the things you have to watch with graphs, and I find this a lot when, like, say I'm reading like a news report, I'm reading a scientific paper, and you see the graph, and say you look at one on the left here, and you look at that, and you're like, oh wow, there's a lot of change, right? If this is position versus time, there's a lot of change in position, with time, and that's true until you look at the scale here. So you look at the scale, and you notice, oh, this only goes from 200 to around 245. And if I were to change my scale and start at 0 instead and plot the same data as I did before, now that change doesn't look so much. So one of the things I want you guys to pay attention to when you're looking at graphs, either in the newspaper, or if you're reading, if you go on and you go into science engineering, you're reading an article in science engineering, and someone's trying to convince you of something, pay attention to their scale. Okay, and the scale a lot of times can affect how that pattern that we talked about in the previous slide is perceived, whether it's like a big change or a little change. This change on the left side looks a lot bigger than the change on the right side, but really it's the same change for both graphs. Okay, and so it's just a perception. So a lot of times you can kind of see that perception with your scale. So be on the lookout for that. So as I said, the main use that we have in physics for graphs is that it shows relationships between variables. And so when we say a relationship between the variable, what we're talking about is the equation that relates two variables together. So I have some examples for you. So say we were to graph force versus acceleration, and we get a graph that looks like this, and this is a linear graph. Okay, so we would say, oh, okay, so this is I could say that this is a direct relation between, so B/W is between force and acceleration. Or you could say that it's linear, it's a linear relationship. Okay, both of these work. Now, be very careful with direct relation. In science, when you use the term direct relation, you mean a linear relation. You mean it's not just that one variable increases when the other one increases. It's that when one variable increases, the other one increases by a constant amount. Okay, so it's a linear relationship. And so what we can say is that we may not know the exact equation. You could fit this certainly to a line and find the equation. But what we would say is that the force is proportional to, so this little alpha fishy looking thing means proportional to. Okay, it's not an equality. Okay. But it says that they are related together. So force is proportional to just the acceleration. Okay, and there might be a constant in there, and we could get equality, but this proportionality tells you that there's a relation between them, and this is stating that they're directly related to each other. Okay, now we can look at another graph, and this one is position versus time, and we see in this graph when as time increases, the position's increasing as well. But it's not the same as the one over here on the left. This one curves. Okay, so we would say that this is a nonlinear relation. Okay, this is a nonlinear relation, and actually, there's lots of mathematical equations that make curves that go up. Okay, and pretty much any what's called a polynomial, so like x squared or x cubed or x to the fourth, you can arrange it so like it kind of curves up. So for now, let's just leave this as a nonlinear relationship, but very often this will be like an x squared relationship. And so you would fit this, and actually, since I made this graph, I could tell you that I could say that the position is proportional to time squared. Okay, so in this case, it's not a direct relationship. Here, force was proportional, just directly proportional to the acceleration. Here, position is proportional to time squared, and because of that, we have this kind of half a parabola looking curve along here, and that's a nonlinear relationship. But again, using graphs, we can see that. Using Excel, we can actually fit this to a function, and later on in the course, we will do exactly that. Okay, so these are two very common types of relationships between variables. And then there is a third one, and this is, mass increases, in this case, acceleration will decrease. And we would call this an inverse relationship. Okay, so this is an inverse relation. As my mass increases, as one variable goes up, okay, so as mass goes up, my acceleration will go down. Okay, when that happens, when one variable goes up and the other goes down, we say they're inversely related to each other. So what I could say is that the acceleration, I'll just call that A, acceleration is proportional to 1 over the mass. Okay, because it's 1 over mass, as mass goes up, acceleration is going to go down. So this is what an inverse relationship would look like. So what we're going to do in class is we're going to look at different types of graphs. I'm going to ask you guys to just, graph them and look at the relationship between the variables and state what that relationship is. And then really throughout this course, we will, especially in our labs, I'm going to ask you guys to make these graphs because a lot of the labs that we do, the purpose is to find a relationship between two variables. We do that a lot in physics. Okay, so I hope this all made sense. If you guys had any questions, please let me know.